And I'll leave this independent stuff up. I need some room in here. All right, on this day 5 notes, I would like you to draw a chart that didn't make the first printing, but it's such a small chart, I didn't feel like giving it to you, so you can give it to yourself. Here's the chart, and it's talking about males and females, and it's talking about, are their ears pierced? And we're just talking about ears. The ears, this is an old book, yes and no. All right, so the numbers, and they looked at 178 people.
I think this chart's on day 5.
Yeah, I think so too.
What's that?
The chart's on day 5.
What do you mean?
Or at least,
it is? It's
or at
on
least
the wrong
the
day?
problem is, yeah.
Okay, cool. All right, well, we don't need that. That's right, we already talked about that. We're going to use that again, so you can just pull it out and put it. I didn't copy it again. So there were 19 and 71. So that's 90, 84 and 4, that's 88, totaling to 178 both ways, 103 and 75. So sketch that down again so it's right in front of you on your day 5 notes. Now we're going to discuss things with our new symbol, because we're so excited about our new symbol. All right, sometimes I slant mine, I don't know where I got that from. It is supposed to be a vertical line, so forgive me when I forget. I'm forgetful, that's the way it is. All right, the probability of male given pierced. All right, we're supposed to look at that chart and interpret that symbol. Brian, what do you think? What box am I aiming at? What numbers? The probability of male given pierced.
Oh, I see why it's conditional.
I
get it.
Probability of male given
Oh yeah, I
that
do see them.
It's
has
pierced.
given that has been pierced. So would that be like 19 out of 103?
Exactly. He nailed it. He pierced it. All right, so here we have the given. I always start in my brain on the given part. It says given pierced, so that means I'm stuck. I'm stuck in that column where everyone is pierced. So from that, I want to know the male number, male over 103. It's just like a conditional distribution that we've seen earlier. So, all right. So didn't it seem simpler this time?
Yeah, I kind of like this a little better.
All right. What's the probability of pierced given a male? We'll switch colors for that one. Pierced given a male.
Sorry, Emma, the camera won't stay where it is.
19 out
I'm having to adjust it.
of 90.
All right, so given the
No,
male,
it just
so
keeps
we are stuck with males only. So we're only going to look here. So it is how many of those are pierced? 19 out of 90. So this was 19 out of 90. So what was the other one? 19 out of 103.
Yeah.
So notice how we went on different parts of the chart, one vertical and one horizontal, got totally different numbers. All right, let's try that. Do I have a check your understanding on this page?
Yes.
Yay! All right. Let's try this one. Oh, I wrote the totals in, didn't I? Somebody did. All right, I hope those are correct. All right, on this check your understanding, on the day 5 notes, we are looking at a situation where we have 3 types of schools: liberal arts, engineering and physical science, health and human services. 3 areas of study. And the grades are A, B, and below B. So the person looking at the study is thinking that engineering and physics are harder, so the grades are going to be lower. That's their thought. So they're going to look at some conditional probabilities and see what comes up. So on the first question, it says just find the probability of being a liberal arts student just in general. So the probability of being L. So that's not conditional at all.
6,300 out of 10,000.
3,000, how many?
6,300 out of 10,000.
3,300.
6,300.
Oh, 3,000, I didn't get that. How many liberal arts students are there? 6,300?
Yeah.
That's what you said, isn't it?
Yeah.
Okay. It's not what I have on my paper, but I think you're right. All right, you are right. All right, so looking at all the liberal arts ones, there are 6,300 divided by the total 10,000. All right, I'll go with it. All right, hope my next one's right. What's the probability of being an engineer given you are getting lower grades, L for lower? Probability of engineer given lower grades. So,
that would be below B?
MK, you talked me through that one. Brian's been getting them all right.
Would that
so.
be L is equal to a grade lower than
Low, oh yeah. Probability, this is L's for lower grade. So, that's a little confusing, but that's what I mean. Low grade.
Does that mean below B?
Yeah.
Yeah.
Right, below B.
Alright.
For you guys, it would be B, but
Not
we
for
won't go there.
me.
We won't go there. All right, so. All right, MK, no MD here. Sorry. I'm so used to calling on you, I still call on you when you're not here. All right, so go to the low grades and do a probability with E, with engineering. So what numbers?
Probably 800 out of 1,656.
Right, do you see where you're gonna give me that number? She went to L for lower grades, went below B, and she stayed in that column. She pulled out the 800 for engineers, and she put it over the total. 3656, is that what you said?
Yeah.
All right, and last, let's switch it the other way and do the probability of getting lower grades given an engineer. All right, so try that one,
Wait, it's a probably of lower grade, that's what the L is?
Yeah, probability of low given engineer. So which row or column are you going to stay in?
You're gonna stay in... Are you just gonna stay in the row this time?
It depends. It depends what's here. We always stay in whatever's in the
Yeah.
problem what's here. So is
So
that
it's a row.
row? So
is that
second
just-
row. So you're going to pull out low grades
800.
out of
1600?
right.
Is that what
So
this is?
half of them. All right. Is that enough information to answer the question? That's all they really asked us, but
Wait. Which one tells you that the students earn?
what else would we have to examine to really?
The
This
other
tells
ones.
us 50% of engineers, given you're an engineer, are getting lower grades below B. So how would we answer the conjecture? Is that lower than the other disciplines?
You have to look at the other ones.
Right, you do. So we're not going to go there. We're really just practicing. We're not really trying to answer this question. We're practicing conditional probabilities. But you'd have to do that with social sciences, or what are they called? Health and
Liberal
Human
arts.
Services and liberal arts. You'd have to get those numbers and see how they compare. All right, so that's an example there. Let's try it one more time on the back. So turn over and let's look at left and right-handedness. That's called handedness. And gender. So do you suppose there might be a conditional probability, or do you think there's a connection between gender and handedness? So let me get this down. All right, let's walk through this as well. Looking down at the bottom, I'm looking at that chart now. There's 28 students, and one of the questions asks whether each student was right or left-handed. The two-way table summarizes the class, and choose a student from the class at random. The event of interest is female and right-handedness. So let's see what we can get out of that. What's the probability? And So, are they independent events? So we're going to see if they are connected. There's a connection. And we're going to test to see what is the probability of being a female given you're right-handed, and then the probability of right-handed giving you're a female. And if it's independent, that means one doesn't affect the other. So we're going to compare that to what? I just erased it, but you have it on your notes. If it is independent, I'm not sure if it is, what will that equal, Brian, by our definition of independence?
Equal probability of this being.
Exactly. If this is the same, then this R didn't matter. And then we have to check it the other way. So Brian, what will we look for on here?
Probability of being right-handed.
So we're going to do all these probabilities and check and see if we have an equivalence or not. What is your thinking? Do you think that there's a connection? I've heard that males are more left-handed.
I don't
Have
know.
you heard that?
I feel like I know more guys that are left-handed.
Yeah, for some reason I do too. All right then, let's start down this path then. So Brian, you start, and there's 4, one for each of us. You take this, I'll take this, MK and MM, and we'll see what numbers flush out. Can you look at the values in the chart and tell me what is the probability, Brian, of being a female given you're right-handed? I don't have the totals in there, so we got left, right, 3, 18, female, male, 1, 6. It's only 28, remember, in the class. All right, so here's all our info. So Brian, what is this value? And I'll put it.
3/4. We're 18 out of 24.
All right, so you stayed in the right-handed row because it was given right-handed, and you picked the female, 18 out of 24. All right, I said I'd do this one. The probability of just being a female, and that's it in this class. Where's my females? Right here. There's 21 females out of 28. All right, who's got their calculator visible? MK, give me, what is 18 out of 24? What was it?
0.75.
75%, I think that is as well, right?
Yep.
All right, so it looks like so far we're on track to say these events are independent, but it has to go the other way. So, MM, who did I give this to?
Me.
All right, MK. What is the given right-handed given female? What numbers are you using?
18 out of 24, 21.
All right, so you're staying in the female column and you're picking right-handed. 18 out of 21, I agree. All right, just plain old probability. That's not R, it's a P. Probability of being right-handed.
24 out of 28.
Right. All right, check those.
They're the same.
What percent?
Oh man, I just deleted it. It's like 86%.
86?
Yeah.
Okay. 86%, and they're both 86%. All right, so that's how you prove that two events are independent of one another. So even though I thought that I knew more males that were left-handed, that there was a connection, they are saying that these events are, at least this class has the statistics from this class have shown that they are completely independent. All right, do you see how that works? If you're asked to do it, would you be able to?
I think so, yeah.
All right. We're going to bleed into day 6, so I'm not going to give you the day 6 notes yet because the actual day 6 notes are full. So you couldn't even, there's not even a place to take notes. So what is that? What's that?
Do we need to like
Sorry,
break
yeah,
it into
true.
parts?
Yeah, I can split it into parts.
Rusty
But
at
go
this.
ahead and shut down now and start
Okay.
again. I forgot to split it up, but I know how to split it up. So. All right, we'll be back in a sec.